Speaking of coterminal angles, one of the most commonly missed questions on the next quiz, okay, is something similar to this. The expression for all angles coterminal with 60 degrees. Okay? All angles coterminal with. So we just did an example where we found coterminal angles by adding or subtracting 360. Okay? Basically what we're going to do is we're going to add or subtract some multiple of 360. Okay, we're going to add or subtract some multiple of 360. Or another way of saying that is 360 times n. Okay, n just being any number you want to make it. You want to add 360 twice. If you want to subtract 360 3 times, you'd make n negative 3. So we would take 360 negative 3 times. Okay, so here it is. If you want an expression for all angles coterminal with 60, you can start with 60, and you're going to add 360 in. Okay, get that down. Okay. Get that down. I'm telling you right now, that's a very, very commonly missed problem on a quiz or a test that's going to come up. Okay? And you'll see it more than once, too, and some of you will miss it more than once. So don't be that guy. All right? Make a note of it. Make a point of it now that you're not going to miss that question. That's all angles coterminal with 60. And so what if I said all angles coterminal with 45? Well, you'd say 45 plus 360 in. If I said all angles coterminal with 180, you'd say 180 plus 360 in. Okay, it's always going to be plus 360. All right, and so then in this chart they give you some examples of 2 times 360 and 1 times 360 and 0 and negative 1, and they give you some specific examples of coterminal angles. This and this and this and this are coterminal. That doesn't mean those numbers are equal. That means those angles end in the same spot. Anybody know what quadrant we're in? Easiest to tell with 60. That's in quadrant 1, right? So all those things are in quadrant 1. They end up in the same spot in quadrant 1. Okay, example 6, maybe the hardest question of the day. Analyzing the revolutions of a CD player. CD players always spin at the same speed. Suppose a CD player makes 480 revolutions per minute. Through how many degrees will a point on the edge of the CD move in 2 seconds? Question mark. Okay. So you've got a CD here, and we're looking at a point on the edge of it, and we're wanting to know how many degrees a point on the edge will move in 2 seconds. So it's spinning around. I bet it spins more than once, so more than 360 degrees. But let's just see. Now, there are multiple ways of doing this problem. Here's the way I see to do it. Okay. Start with the number that they give you. The only number they really give you is 480. So I start with 480 revolutions per minute. I like to set this up as a unit analysis problem. If I look at the units, sometimes the units can guide me to my answer. I need to end up at degrees, right? I need to end up at degrees. So let's figure out how to make it into degrees, okay? Well, I know there are 360 degrees in one revolution. This thing rotates around one full turn. That's 360 degrees. One revolution equals 360 degrees. So what I can do is multiply by 360 degrees per one revolution. And what the units tell me is those revolutions would cancel out. And now I'm in degrees. I'm in degrees per minute, though, and I don't want degrees per minute, okay? And so I notice they give me something about 2 seconds. So it might be nice to change my minutes into seconds, okay? And so my conversion factor for minutes and seconds, I know 1 minute equals 60 seconds, right? 1 minute equals 60 seconds. So what I can do here is multiply by 1 minute over 60 seconds, okay? And I notice that the minute would have to be on the top so that I can cancel out with this minute over here. And so now just look at the units. Whatever my numbers do, I'm in degrees over seconds. I'm in degrees per seconds, okay? That's not exactly what they want me to have. They want me to end up in just degrees, okay? And I still haven't used this 2 seconds. And so all I'm going to do at this point is just multiply by that 2 seconds. If I multiply by that 2 seconds, that's going to tell me the number of degrees that I go through. And so just looking at the units, I know that I'm going to be on track because all I have left is degrees, and that's what I want to end up with. So when you calculate this, anything on the top of your fraction gets multiplied, anything on the bottom gets divided. So I'm going to go 480 times 360 times 2 divided by 60. Okay, that ought to get me there. That equals 5,760 degrees. That's how many degrees this point on the edge of the CD would rotate through in 2 seconds. Now again, that's not the only way of doing this problem. Chances are some of you found a different way of doing it that makes more sense to you, and that's fine. Okay? I'm not telling you the only way of doing the problem. This is just the way I see it. Questions?